So everyone, we're going to give it just a couple of minutes for people to dial in. Today's meeting is going to be something we've talked about for a while. Just to recap, for those who are new, we are running a case study around automation in the OpenChain project. We started in September, and we will run the first phase of the case study until December 16th. This month, we're in the middle of looking at technologies in a little bit of a deep dive. 2 weeks ago, we had an analysis of how to do scanning for license compliance using a tool called ORT, Open Source Review Toolkit. Now, this particular tool, of course, is extremely capable, and it is already well used in the industry. But our demonstration looked at not only how the tool works, but how you can call it super simply with a graphical user interface. In a way, our case study is about a journey where you can use graphical user interfaces to quickly scan code, or you can dig into the tools with the command line and other ways. Today, it's container time with Tern. Tern is a project which originated with VMware, and it's now housed in the Linux Foundation under an umbrella called ACT. Tern has several years in the market and has been used quite widely. We're going to look at Tern as a technology, and we're going to look at how the graphical user interface I mentioned before can call Tern quickly and easily. Before we begin our meeting, I'm just displaying our antitrust policy notice. We show this at the beginning of all of the meetings around the OpenChain project. You can read the full Linux Foundation antitrust policy on the website, and if you're from a member company, you can always reach out to our counsel, Andrew Updegrove, with questions. But let's dive right in. The gentleman behind the graphical user interface that we're using is called Max. It's Max Huber from TNG in Germany. He and his team created this in collaboration with Facebook, and he has been guiding us through the case study from September and will continue to do so until December. So just like before, I'm going to hand over to Max to run this call on using the GUI to run Tern and to dig into the Tern internals. Max, over to you.
Hey, thank you, Shane. And I think I would nearly directly forward to Rose. She will give us an explanation or some background why Docker images are in particular hard to grasp and hard to understand, but also will go through how the tool developed by or contributed by VMware called Tern helps to mitigate that. And please, Rose, you could start now if you want, and please give us an introduction into Tern.
Okay. Give me a second to get my slides up. And okay, can you see this?
Yeah, we can see it.
All right, great. Hello, so thank you for having me here today. My name is Rose Judge. I work in the Open Source Technology Center at VMware. And today I'm going to talk about Tern and its place in the cloud native compliance ecosystem. Okay, there we go. So while today's presentation will mostly be about Tern, I do want to start by giving just a quick introduction to containers and the compliance issues we see with them, which also happens to be the why behind Tern's inception. And then after covering Tern and a demo, I will be happy to answer any questions after Maximilian does his demo. So I'm sure you've all heard of containers. Maybe you've even built one yourself, or maybe you haven't built one, but you ran a container.
We have a bit of noise there. I'm just going to mute some people.
Thank you. So maybe you've ran a container, or even if you haven't interacted with containers directly, you've probably interacted with them in some capacity indirectly. Most cloud workloads are containers, as well as most cloud infrastructure components, and then all cloud native applications are containers. And when we hear the word container, we tend to think of the actual thing being run. One small distinction I want to make is between a container and a container image. A container is just a Linux process forked in its own namespace and with its own namespace constraints. That is what actually gets run. A container image is what gets distributed. So it's essentially a stripped down Linux file system broken down into a series of tar archives. And it's the actual artifact that gets inventoried and contains the actual binaries that we want to know about for compliance purposes. So to give a little context for the rest of this talk, I want to look at how we typically build containers. So you would start with this from line in your Docker file. So this is what we refer to as the base OS. And it's important to note that this is oftentimes someone else's image. So you're typically pulling this from Docker Hub, or it could be from another registry, but from a repository that you don't control typically. And all of these files from your base OS are basically a Linux file system, which provides basic configuration files and tools. And then, as I mentioned, this base OS will typically come from someone or somewhere else who you may or may not trust. And then on top of that rootfs, you're going to use the system tools to install dependencies, which are required for your app to work. And then finally, you would add your application on top of all of that, which is the whole reason why you're building this container in the first place. This is what you're going to run, but the whole stack here is what you're going to distribute. And this is all well and good. This is how software installation typically happens on Linux distros. And when it comes to container build tools, there's a lot of them right now that use this layered approach. So tools like Docker, Bitnami, Cloud Native Build Packs, Docker probably being the most ubiquitous. And with the default build mechanism of these tools, they're not perfect, but there's some level of scrutiny and control. So when it comes to trying to determine what's actually inside your container, it's a bit of a jungle out there. The image on the right is a dependency graph for the Kubernetes Go module. And this may be a little bit of an extreme example, but as you can see, or in this case, not see, because the text is so small, there's a lot there. And buried deep underneath it is maybe one weak link, not as strong as we might imagine, which has potential to destabilize the whole system. So in order to secure our container supply chains and be compliant with any open source licenses, we need transparency. We need to know what we have in our container and the implications it may carry for our container supply chain. And a software bill of materials is the starting point for transparency, which probably comes as no surprise to this group. One of the reasons it's so hard to determine what exactly is in your container is because the build files we use are typically not declarative. So even when you build your container using a reasonable layered approach like Docker tries to do, we're still faced with this dependency jungle issue. So what you see written in your Docker file is not necessarily what you get in that final image binary. The executable lines in your Docker file are just the tip of the iceberg, if you will, and all of the component metadata is what's actually underneath the water. And when this really starts to be a problem is when it comes to security and compliance, because you can't comply with the open source licenses of components if you don't know what they are. and you can't patch a security vulnerability for a component if you don't know that it's included in your container. And this is all indicative of a much larger problem in cloud native, which is that it's a very complex and tangled ecosystem. There's a large number of software components. Developers don't know what their software includes, and tools don't collect enough metadata to reason about the dependency chain. Build systems are not reproducible. During build, your Dockerfile talks to the internet at build time, which means that building from a Dockerfile is non-deterministic. So for example, many Dockerfiles use based images based off a tag that may not be available in the future, or they install software from random corners of the internet using wget or curl. What's included in the container is dependent on the state of the internet at the time of build, which makes it incredibly difficult to reproduce the same container in the future. And then it gets worse. When we use some of these tools like Docker Cloud Native Build Packs, they use a reasonably layered approach, which we just saw a few slides back. And when using those tools, there's some level of scrutiny and control that goes into these builds. So you can think of this build process as the image on the left, right? A nice layered smoothie. But what about the ones that don't follow this recipe? Instead of a reasonable layered parfait style container, you sometimes get these container images that are more like a smoothie. You know, tools like Docker Slim or multi-stage builds that are designed to reduce the file size of your container by stripping out files and metadata. While these tools can be useful to practice runtime security measures, because technically you're reducing your attack surface, they're a nightmare for trying to understand and reason about what exactly is in your container as all of the metadata gets stripped out. So how do you know what's in your container? While there are ways that you can do this manually, Tern is a tool designed to help you automate compliance for containers. So as it was mentioned, Tern is an open source tool. It's a container inspection tool that originally began at VMware before being donated to the Linux Foundation. It's written in Python, and it produces a software bill of materials for a given container image or Docker file. If you specify a container image for Tern to inspect, it will pull the image from the registry, untar the layer blobs, and then sequentially mount them. And at each layer, utilize various scripts and utilities to collect package metadata, which it then organizes into a formatted report. So this is a picture of the general workflow. And I'm going to run through a demo, but the default report that Tern produces will look something like this. It will list file and package metadata. And the package metadata it gets from actually using scan code, which I'll get to that in a second. This is a screen grab of the default report. So it has metadata that we tend to find people request more, like version, license, maybe the package format. But we do have other reporting formats as well that include more metadata. So quick overview summary of Tern's capabilities. Tern has the ability to inspect container images, both post-build and at build time. The inventorying at build time is a new feature that the other maintainer, Nisha Kumar, just demoed at KubeCon a few weeks ago. So that is available if you want to check that out. Today, I'll demo the standard use case, but Tern can also generate an output report for Dockerfiles as well as container images. So instead of taking a container image binary, you can give it a Dockerfile, and Tern will try to build the Dockerfile and produce an SBOM for it. Another popular mode of operation with Tern is its ability to integrate with other analysis tools. So you can hook in any analysis tool you want to, but Tern has default support for scan code, which is a file and binary level analysis tool that some of you may be familiar with. It's also open source, and Tern will expose the container file system to it. It will collect the metadata from the tool and then merge it with the native package information into Tern's data model and produce one cohesive SBOM from it. The SBOM that Tern produces is available in a number of formats. So we have JSON, YAML, HTML, SPDX tag value, SPDX JSON, and CycloneDX, and then soon to be Possum UI. One important point that I also want to make about Tern is that it is vendor neutral and it aims to be transparent. So this means that Tern will list known unknowns as well as the known metadata it collects, but it doesn't make any judgment about what it finds. And that's because transparency isn't about dictating what's good or bad. It's about providing enough information that allows folks to make informed, risk-based decisions for their own use cases. So Tern aims to provide that visibility up the supply chain. And as a result, we hope to empower users to reason about things like compliance, maintainability, and usability for their containers. So like with any type of software, there are limitations to be aware of, and Tern, of course, is no different. The first drawback is that Tern's default analysis relies on the existence of a package manager and a shell to collect all of the packages and their metadata. These two utilities will be present in most base OSs, but when you have a stripped down container, there are edge cases that may not contain these utilities, and in those cases, Tern can't tell us much about them. Granted, you're not really going to find a tool that can tell you, a container analysis tool that can tell you much about anything if there's no shell or package manager, but Tern, of course, falls into that same category. Next, Tern relies on the correctness of the package manager. So if the base OS you're using records its package metadata incorrectly, then Tern will read that incorrect metadata. And this is probably not a huge factor when you're working with some of these big box operating systems like Debian or Ubuntu, but still something to be aware of. And then lastly, Tern currently requires root privileges to run, so both in a container and natively on Linux. And that requirement stems from some of the mounting that happens during operation. But currently, we're actively working to remove some of those privileges so that Tern can run in an unprivileged container. And there's a successful proof of concept underway for that. As far as adoption goes, because Tern is an open source project, it's hard to say exactly who is using it and in what capacity. The project has 600 stars on GitHub, so we assume that there are a fair amount of users. Oftentimes we know of these users when things break because they start to open issues, but in addition, we're also aware of these companies and organizations who are using Tern in some capacity, typically from what we've seen in their CI/CD or developer workflows. And my last slide before the demo is about interoperability and how Tern can work with other compliance tools out there. As I mentioned, Tern is extendable to other file system analysis tools. So for example, ScanCode. Tern exposes the container file system to these analysis tools, and it can either generate the output report straight from the tool, or with a little work, it can be integrated. We can integrate the output information from the analysis tool into Tern's data model and into Tern output reports. Tern can also generate both SPDX and CycloneDX reports, which means it's compatible with SBOM consumption tools regardless of their SBOM input specification preference. And our latest type of output report that we've been working on is for Possum UI, which Maximilian is going to talk about after this. And the Possum UI format is, if generated from Tern, would then be able to be inputted directly into the Possum UI program. All right, so I'm going to stop this here. And let's try this. Okay. We'll deal with that there. So the most basic use case for Tern, I'm not going to I'm not going to run a scan code Tern with scan code because it does take quite a while. But this is how you would generate the basic report. So you can install the pip package, you can clone it from GitHub, and you would run Tern report-i. You would include the image. Photon's just a really simple basic image. And then if you wanted a different format, you could specify it with -f. And if you want an output file, you could specify it with -o. I already have this run, so I'm just going to let it output to the terminal. And we'll run it like this. As I mentioned, it does require root privileges at the moment. So I would enter my password there, but here's that default report that you're going to get. So it's going to break it down by layer. So Photon is just, it's a base OS, so there's only one layer. But because I have run scan code on this image before, that information is cached. So it's able to also tell me the file licenses found in this layer. It's going to tell me the information about the layer or the command from the Docker file that created this layer. It's going to tell me what that base OS is based on the etc OS release file. And then it's going to tell me how Tern actually gathered this information. And it's using this DNF package manager. There's a file that you can look at that gives you a breakdown of all the package managers and the scripts that we run to collect the metadata based off those package managers. And then it will give you this. So these are the packages it found, the versions, licenses, package format, and then a summary of all the licenses. So if you don't care about the breakdown and maybe you just want to know all of the licenses in your container, here it is. I also had generated, so this is the very basic default format, but I've also generated this JSON file, which you can see is contains a lot more information. So I know that this, so if we look at this file from scan code, this is all metadata collected from scan code. It could be the license expressions, copyright licenses, and yeah, and then using Possum UI, you could edit this information. So if you saw a license collected that you knew was not right, or maybe there were 2 licenses collected and you just want to establish one of them as the working license for that package, you can do that in Possum UI. And I think Maximilian will show that next. Are there any questions here before I stop screen sharing?
I just wanted to say thank you. That was an incredible overview and both really easy to understand, but it demonstrated the potential. Super glad to have you here.
Thank you.
Yeah, I have a question. I'd like to know if it's possible.
Hi, Sebastian.
Yeah, I'd really like to know if it's possible to use the DNF package manager, for instance, in combination with an application layer such as pip. Can you get a result from both of them at the same time?
Yes. So here, let me see if I have. Let me generate a scan and then I can show you. It does it collects pip, collects gem, Go modules, and as well as the standard package managers like RPM and TDNF, stuff like that. Is that your question?
Yeah, brilliant. So it's a full stack tool. You can use it for all parts of your container stack.
Yes.
Thank you.
Okay, are there other questions? Then I might just continue with the Opossum UI side and how that view of the output from Tern looks like. So that is the that's way smaller. So that is the Opossum UI that shows the content of a Docker image. I've chosen a way too complex Docker file, so that is the Docker image corresponding to Tomcat. So it contains several layers. It contains a base layer. It contains several layers that install dependencies. It contains Tomcat itself, and it contains sub-layers that are just for technical reasons there. And I want to show how the UI view can help to get a better understanding of that and how to review that information. So the here in this view, it's displayed as a view of layers. So every layer gets a number for each. So the layers are ordered, and that is used to give them numbers. And for example, I can just click at the first layer, and immediately I get a lot of information. The first interesting thing that is shown here is that additionally to Tern, I have also inputted the information that the scancode.io tool generates when the corresponding scan pipe configuration for Docker is run. So we have even more information than just in quotes just scancode, just Tern here. And so the first interesting thing is that both scanpipe and and Tern report how the layer was generated. So I can see the first layer was generated from some initial base file. So that's how the first layer is generated. It's not generated from CLI commands, but there was something generated that is now the first layer. And I can see what dependencies are there. So for example, Tern reported that TZ data is there, Perl base is installed, and I can even dig deeper and see, if I click here on this magic icon, that this Perl dependency is present in layer 1 in these files. So for example, user bin Perl is obviously part of the Perl package and present here. And if I click here, I can navigate to the corresponding file. So I can see here that file is reported by scancode and by Tern, both as part of Perl base with the correct version. So that is the first thing that you can see in that UI. And if we go through, we can just look at other layers. So I think maybe layer 6 is interesting. So that just contains one single file, and I don't understand what's in there. So I look at what command was used to generate that layer. And I see that was just a bash command that wrote some string to that file. So I can see that's fine. I could even resolve that folder here and say, let's give that a new attribution that's part of, or that's, yeah. I need to give the final thing a name. Let me just call it Tomcat image stuff. That is completely not accurate and not very helpful, but just for me right now, something to mark something as green. And I click also exclude from notice. I don't want that string to appear in the final notice, for example, but I can see now I have more stuff green, and I can go through and finish all the files and make everything green, and then I have understood everything if I want to go that route. We also have this overview view that helps to understand what packages are in there and where they are found. So that's an interesting bug. There's something for us to fix. But we can see that both scancode and Tern report very similar things. The lists look different since they are differently ordered, I think. I need to look into that. And there's also this report view. But yeah, that's one can use now this UI to dig into that and to fix stuff. The maybe just one other way of how one could dig deeper or look deeper. I can see this layer 2 was generated by installing the dependencies CA certificates, curl, netbase, and wget. And if I look here, I see yeah, OpenSSL was installed. I might know that, but that's probably a dependency of CA certificates, but I can now see OpenSSL is installed. I can understand which files come from OpenSSL and which files are attributed to that package. And I can also see all the license findings that scan code produced in the scan. So that this signal could either be provided by Tern or by scancode.io. But I can now see here all the licenses that are found in the source code. And I can see, oh, there's potential GPL files. I can look there. It's a file that is also attributed to libkeyutils. And interestingly, that's a file that is not attributed by the scancode.io tool. So maybe that's the first difference we see between these two tools, but that demonstrates that there is a benefit in having the possibility to have multiple tools. And one other thing is, since Philippe is on the call and he knows everything about scancode.io and he maybe built most of it, I think that scancode.io has different limitations compared to Tern. So I think scancode.io does not depend on the package manager so much and on the layer to be executable or to be runnable or to have a shell. So that's one reason why it's useful for an ecosystem like open source compliance to have multiple tools. I also would like to go in to look at that from a different direction. So that output here was generated with the opossum format. So that relied on having a converter from scanpipe or scancode.io to opossum, or that relied on having the custom Tern output format from to opossum. But there's also SPDX. And I can open the same file from generated directly from SPDX. So that here is, this is now generated by running Tern on the same Tomcat Docker image and producing SPDX and importing that in this opossum UI tool here. And if I now expand that file tree, we see that this is slightly harder to understand since the layers are not renamed to be layer 1 and layer 2, but they are displayed here with their hash. But other than that, we can dig into these layers and see which packages are installed in this layer. So there's also SPDX support that allows to get this information into opossum UI. But the result is currently less convenient and less complete. But we are working on improving that and getting maybe in the future have a result that does not rely on the custom intermediate format, but be able to directly import SPDX. So that was a short update on, or a short summary on the UI. And And one last thing to the SPDX import, that should be able to import arbitrary SPDX 2.2 JSON or YAML, and should be able to visualize the content in this UI. So that's even more universal. So with that, I would say we would open the floor for questions. Maybe also more questions to Rose, and maybe other questions related to the UI. Are there any questions?
So we have quite a lot of people on mute. We should probably just give them a chance to unmute if they're currently talking. I noticed that there was some conversation there about scan code, and Philip in the chat said that everything's being contributed and worked on at scancode.io. So it's a good space for looking at source scanning, apparently. Now, it seems that the community around scan code is quite vibrant as well. So collaboration across different projects seems to be going relatively well. Max, do you find it difficult to coordinate? Because we have quite a lot of projects out there.
For me, it's not so much the coordination, but to get all the outputs passed. So that is difficult. But I think both projects are very valuable contributions to this ecosystem, since they have orthogonal approaches, as far as I understood, and that's something where Philippe maybe needs to interrupt me. But as far as I understood, Tern runs mounts every layer and runs tools, and scancode.io extracts the layers and runs scancode analyzers to extract their information without relying on running the tools. So it's interesting to see both working so well and to producing rather similar outputs. So even the numbers, how many files correspond to each package, are very similar. There's a difference of 2 between GPT agent and yeah, it's interesting to see that, and it might also help the development of the tools to see these differences here.
I would also just Maximilian and Philippe are part of the Automating Compliance Tooling work group, which is hosted by the Linux Foundation, and it's essentially a handful of tools that help automate cloud native compliance, and we meet every other week trying to kind of iron out some of these compatibility issues between tools, as well as just general issues that we see in the compliance space. So there are a lot of tools, and as Maximilian said, I think the input format between these tools and parsing that information is definitely an issue, but we do have a working group where we discuss these issues. So I am hopeful that as time goes on, this will become easier, which is good for everybody, because the easier compliance is for users, then the more it will be done.
There's a question in the chat. Let me just read that out. After producing an SBOM from a container image, what might be some next steps to get closer to compliance when distributing it, such as automated ways to providing corresponding source or copyleft components? Rose, if you want to answer that.
Yeah, that's a really good question that I don't have a good answer to. I don't think there's that's something that compliance, especially container compliance folks, discuss a lot. There's efforts in the OCI community to not distribute copyleft sources, but just even try to distribute the corresponding SBOM for a container image. And that's taken a while just to even try to figure out a mechanism for being able to do that that's compatible with the registries we have today. I think that this is like this is a gap that I assume another open source tool or proprietary tool will try to fill, because the distribution, I have a whole set of slides about like gaps in cloud native compliance, and this is one of the huge gaps, is just the access and distribution. So even if we were able to figure out a way to efficiently distribute these SBOMs with their container images and potentially sources, like there might be parts of the SBOM, especially for proprietary code, that, you know, contains privileged information that only certain parties get to access. And so trying to figure out a way to control, you know, to provide access control for some of these SBOMs, and then also an efficient distribution mechanism, it's a real challenge and something that there's not a clear solution for right now.
Mhm.
Yeah, Rose, that's absolutely true. It is a big gap, and it's one that's really going to start impacting people. There very recently been 2 lawsuits lodged against a couple of organizations for not distributing or not making available the source code for their GPL or AGPL registered components. And that's one problem that we found with containers, is that when you only do the scan at the binary level, at the layer level, you don't get all of the licenses that are actually at the source code level. So you really need to have the source code in order to do and generate an accurate SBOM that's going to keep you legally on the compliance side.
Yeah, and that, I mean, that's part of the reason that we do provide information about known unknowns in the Tern scans. If there's a binary blob that Tern can't reason about, you know, it says something like further analysis is required, which isn't helpful if you want everything automated. But the number of ways that binaries can end up in a container is almost infinite. So, and especially like places that they may be installed from. So it's hard to build a tool that can perfectly, you know, scan these sources. But I mean, I definitely recognize that that's an issue. And I think we're still at a point where there is a little bit of manual intervention that will be required for some of these mystery blobs that end up in containers.
Right. And I think that the part of that problem is due to the fact that the open source community is not acting in the interest of what open source is. If they're just creating binaries, like for example, Docker, and they're not making the source code available, they're already violating open source policy.
Yeah.
So, you know, that's something you can't control, but somehow we've got to get everybody in alignment so that they're providing the source.
Yes, and I think, you know, there is, in the last, I don't know, 5 or 6 months, it feels like there's been a hyper focus on, you know, this SBOM movement and cloud native supply chain security. So I am hopeful that there's more eyes on this now, and more people trying to solve this problem. But yeah, I agree. And that's an important point.
There's also another very practical problem, Sebastian and Chris, which is it's very hard to reproduce a build today. And it's even harder to reproduce the build of multiple packages and whole images. In practice, if you've not kept track of the source code that was used to build all the packages that you use at the time you build the image, it's borderline impossible to get back to the corresponding source code.
Yeah, and maybe it would be good to start out with some of the more stable layers, such as a Debian base image, which can provide the source code for Debian packages. And it'd be interesting to see how this develops over the next few years.
Yeah, these ones are easy. So yeah, base image, they're not super problematic.